going to do a little bit of a demonstration of Vivado under the hood using the Color FSM project. When you bring it up, you can see you can look at the design sources here, such that I can look and see the color lab4.vhd and the color.vhd. I can, once I've edited my color package and my color FSM, I can do a build by clicking on generate bitstream down here. Click on that. So go ahead and do the build, yes. Upper right hand corner, run synthesis design. Initializing design. It's a very small design, so it shouldn't take really too long. Running optimization design. Running place design, place route. Now this is the last step. It's running write bitstream. And that's completed. We're going to open the hardware manager. Click OK. Oops. Open hardware manager. Open target. Open new target. Next. Next. It found the Atlas, or the Zybo board, which was switched on. Program device for the Z010 FPGA on the Zybo. Select the bitstream programming file, program. It downloads to the board and the done light turns on. We can also look at other things. If we take a look at RTL analysis, we can look at the elaborated design schematic. Select that. Maximize. And we can see it. Now this is non-technology specific. When we look at the synthesis output, we'll see technology specific. But here we see, RTL registers, by name, next clock, shift register for our debounce, other things, counters. Go ahead and close that. We can also look at the post synthesis schematic, and we'll see a lot more detail. Zoom in a bit. And here you're actually looking at each individual FPGA elements like LUTs, lookup tables, FDRE, which is basically a flip-flop, synchronous reset with enable. You see actual LUTs with, count, clock. You can also look at other reports and things. If we take a look at where we were before, and take a look at the implemented design, we can look at different things like constraints, noise, power consumption. If we go back to him, anyway, I wanted to go back and look at the reports. Here, the different design runs. If you take a look, like these two numbers, worst case negative slack, total negative slack, so long as these are black, that means we're not violating any timing constraints. You also can see whether or not how much of the device is being used. Currently about 0.341% of the LUTs, 0.159% of the flip-flops, none of the block RAMs, none of the DSP that's on the Zybo FPGA. If we go back to reports, we can take a look at I/O report. Double click on that. You see the I/O usage is like 13 pins. Let's change him. Next, let's take a look at simulation. Currently, Sim 2 is active. We'll right-click on Sim 1 to make him active. And then we'll say Run Simulation, Run Behavioral Simulation. Bring him out, right click, full view. If you want to see zoom in on a piece, you'll left click, drag, and then you can expand that part of the display. Right click, full view.